And then I look at the word or. And or stands for either. So either or we say. And that is called a union. So an intersection, two inequalities that meet together. And that's a typical intersection, meet together. Or a union, which sounds like, wow, isn't that the same thing as intersection? A union is two things put together. In this case, you're going to see the difference between and or graphs. So I'm on page now 408. 408. So now we're going to talk about the or, and we'll also review the and that'll hopefully help us to distinguish the two. All right, example number 5. Graph the solution set of x is greater than or equal to -1 or x is less than -4. All right, so I'm done with this right here. It's not necessarily you can choose one, but your answer has to be part of one solution or the other. And you'll see how that's graphed. So example number 5. And this one is x is greater than or equal to -1, excuse me, or x is less than -4. Okay, what's the key word in this inequality or compound inequality? It's the word or, which does not mean the same thing as and. And or are not the same thing. When you want to say that both apply, that's the word and. If either apply, you use the word or. Okay. Let's go ahead and graph each one individually. So just graph them as if you just had that. What kind of circle goes on -1? Close. Line going to the right. All right. And then if you're graphing the second one, -4, what kind of circle goes on -4? Open, line going to the. And at first glance, this is like, Mr. Ray, this is the exact same thing we did the last, or this morning with the and, but it's actually not. Okay, what it's saying is that my solution is either in this set or in the other. Okay, so does anyone know how this would be graphed on a single number line? And don't get too caught up with that because it's a little different than it looks. Would you guys say that there's a -4 there? And there's a negative, I'll go all the way to -1. -2, -1. All right. So this is where it gets a little tricky if you're not paying attention. All right, what kind of circle goes on -1? Close, right? -1. Line going to the...
right. Well, maybe so. Yeah, left.
Right. Line going to the right. Isn't that -1, line going to the right? What kind of circle goes on -4? Open. Line going to the... Wait. This way? They don't combine. They don't intersect, do they? They don't intersect. In most of our examples, they will not intersect. So, Mr. A, I'm a little bit confused. Let me ask you this question, see if you can help me to figure it out myself. Can a number be less than -4 and greater than or equal to -1? Can a number be both of those? No, but is that what we're asking? Are we saying it has to be this and that? No, what are we asking? It has to be this or that. So can a number be less than -4 or greater than or equal to -1? And the answer is yes. Give me a number. Just give me any number that could be either or on this inequality. Yes? Okay. Is -8, which is somewhere over here, is -8 less than -4? Yes. Is it also greater than or equal to -1? No. But did it have to be both? It only had to be one or the other. Can someone give me a number over here that's part of the solution? Yeah, Nate?
0.
Yeah, 0. Is 0 less than -4? Nope. But is it greater than or equal to -1? Yes. So these numbers starting at -4 to the left and negative 1 to the right will all fit that inequality, this or that. What numbers will not fit either one of them? Neither of them. Numbers cannot fit into either one. Yeah, Jackson?
-3, -2.
Yeah, and?
And all the decimals in them.
Yeah, any of these numbers right here. So let's start at -3. Is -3 greater than or equal to -1? Is -3 greater than? Nope. Is -3 less than -4? Nope. Do you see why it's not a part of my solution then? Do you guys get or? It's a little bit different than and. In fact, or and. Can you guys see that? That's normally how it's going to work. Sometimes you'll get exceptions, and we'll talk about that at the end, but this is typically how you're going to graph an or. All right, set builder. Set builder. How do you write it in set builder notation? Now, do you remember with the and, you can combine them into one big inequality? This is how I write it with the set builder with the word or. Ready? X is any number such that X is greater than or equal to -1, or X is less than -4. Is there a special way to combine it? Nope. That's how you do it. That's it. That's set builder for the or. Yes?
That's the only way you write it?
Yes, for or. In this problem, that's the only way to write it. You just put them together and combine them with the word or. Do you guys see that? Is there a special way to write and inequalities? Mm-hmm. Yes, you can do with the two inequalities, x in the middle or whatever variable. Is there a special way to write the or? Nope, just write them each individually and combine them with the word or. That is that part of the problem. Okay, let's go to, I think we can do example 6. I don't think we need it. Example 6. What kind of inequality is that? It's a compound inequality. Is it and or? There's a hint. It's in the problem. It's an or. So, example 6, they give us 3w plus 8. 3w plus 8 is less than 2, or w plus 12 is greater than 2 minus w. So I want you to graph the solution set. All right. What you want to do here is you want to solve. You want to solve both inequalities. So you want to get w by itself here and over here. Okay, so here I'm going to do subtract 8 from both sides. Excuse me. 3w is less than -6. Divide both sides by 3. I get w is less than -2. Did I have to change the direction of that inequality here?
No.
Why not? I have a -6.
You didn't divide by negative.
I didn't divide
Or multiply.
or multiply
By negative.
both sides by negative. Yep, didn't do that. So I have this right here. Or, all right, let's solve it here. I think I want to add w to both sides. So I get 2w plus 12 is greater than 2. Subtract 12 from both sides. I get 2w is greater than -10. Divide both sides by 2. And we have w is greater than -5. That was locked. Okay, so I have these two right now. W is less than -2, and w is greater than -5. Any questions on that? We just solved them. And it's the word, what's the word between them? Or. Okay, so what numbers are less than -2 or greater than -5? And this gets tricky here, guys. This is, I want, sorry? Good questions. Like, that looks kind of weird. Read them off to me again, Jenna. What are the answers we got? W is
W is less than -2. W is or W is greater than
-5. Okay. All right. So here I'm looking at it. I'm going to actually start this off by graphing each one individually. So I'm just going to do it real quick. So -2, open circle, line going to the left. And here open circle, line going to the right. Oops. This is a tough one. This is interesting.
Would you do closed circles? Since it would include them, but it is a less than or greater than, so when you do technically closed circles.
Yeah, let's look at this. I'll take it one step at a time because you're starting to think about it. Okay, looking at these two inequalities, I'm thinking, okay, what numbers are less than -2? -3, -4, -5, blah, blah, blah. And what numbers are greater than -5? -4, -3, -2, -1, 1, or 0, 1, 2, 3. What numbers are, sorry, do you guys notice any overlap between the two? Aren't some numbers that are less than -2 also greater than -5? There's overlap here, but what word is it? Or. Okay, here's how I'm going to do it here. And this is tough, so please pay attention. Don't start looking around, then I don't know what to do. Okay, I'm going to start with -5, -4, -3, -2, -1. Sorry, I went one over. So it's an open circle on -5, open circle on -2, but this one's a little bit strange. Isn't it from -5, it's a line to the right? So guess what happens? You know what happens here? You go right through him, and it would do this. Wouldn't that be the solution set for W is greater than -5? It'd be all those numbers. So that's one solution set. What's the other solution set? From -2, you go to the... So guess what happens here?
Logically, it's closed circle.
Yes. It's all of this. And it goes both ways infinitely. You know what your solution set is?
Everything.
Yeah, and I think it's someone just said it. All numbers. All numbers are either greater than -5 or less than -2. Is there any number that doesn't fit that? That either or. So that's an exception. This is like a weird one, but you should be able to think of it logically. I would say on your homework assignment, I think you have 2 or 3 exceptions. So you get 2 or 3 that are going to be like this, where it's all numbers. So just think it through, and I'll help you out to distinguish how you can know if it's all numbers or not. Let's have you guys practice the or real quick. Number 13 on page 410. Number 13 on 410. This is kind of a more basic one, so hopefully you can get this. 4 plus h. So I want you, to graph the solution set and solve. So you got to get set builder and the graph. So I'm going to solve it first. Let's put those numbers on there. Okay, what kind of circle goes on -7? Closed. Line going to the left. Okay, what kind of circle goes on +1? Line going to the... Okay. So your solution would be any number that is less than or equal to -7 or greater than or equal to 1. What are not the solutions? Any numbers in between those two. Do you guys see that? So how about this? If you can kind of ignore this top part and you're just looking at your graph, is this an and or is it an or graph? Just by looking at the graph. Is it and an or, and how do you know that?
Or.
It's an or, how do you know that though?
Because not all of one problem's number fitting with the other.
Okay, yeah, and even ignoring all that, everything above here, just looking at the graph, what do you know? They have starting points and they go opposite directions. That's usually going to give you an or. What happens if they have starting points and they meet up or they intersect?
It's infinite. Oh,
Oh, so it's just going to be an and, yeah. Those are other exceptions that we have which do come up. All right, how many of you got this? Like you got that one right here? Okay, I'm going to give you one more, and then I'll give you your homework and help you out if you need on some of those exemptions. Actually, two problems, real quick, two problems. 409, page 409, so go back one. I want you to try out number 9. It says, write a compound inequality for each solution set shown below. They didn't give me anything other than the graph. So can you come up with the inequality from the graph? So this is number 9. By the way, do you know if 9 is and or or? It's and because it's an intersection. And then number 10 should be in or. So that'll help you out. Okay. I'm just redrawing it. Okay, we said it's the word and. So does anyone know what that left inequality would be? So you could just take it into, you could start off with two parts and then combine it, or some of you will be able to combine it right away. I'll show you how to do both. So what's the left inequality? X is blah. Greater than 3. X is greater than negative 3.
Or equal to. Oh, no.
Sorry, for the negative 3? Mm-hmm. It's just greater than negative 3. What's the other inequality? It has to fit. Lucy, do you know what that other inequality is here? X is. Say that again.
X is greater than.
Very close. It's less than or equal to 1. Can you see how it's less than that? So it goes off to the left. Okay, can anyone combine it into one inequality? One giant inequality. I'll give you a hint. X is any number such that X is blah to this and blah to that. I know these two know. I will go, yes, Alex.
X is, when you put negative 3, is less than.
Yeah, and see, this is where, keep going. Is that what you got? Yeah, and this is where it's going to take us time to get used to it. Isn't X greater than negative 3? So isn't X greater than negative 3? Yep, it's greater than negative 3. And isn't X less than or equal to 1? Yep, less than or equal to 1. So this is how you describe it. This is your solution sets. X is any number such that X is greater than negative 3 and less than or equal to 1. All right, 10. If you guys haven't already done it, go ahead and do 10. Any questions on number 9? Like maybe you didn't get it? Okay, number 10. I think 4 inequalities are slightly easier to come up with because they're always split up. As you can see very clearly, they're basically just 2 separate inequalities. So this is what I have here. This is the problem. All right, what's the first inequality right here represent? How would you describe this first one? Yes, Emery?
X is greater than negative 2?
Um,
Oh, no, less
less than negative 2. So, right, it's less than negative 2. What's the second inequality out there, Autumn? X is greater than 0. What word links them up together? Claire, do you know what word? Or, because they're going opposite ways, or. And then you want to write it in step builder, so right, you have this so far. That x is any number such that x is less than negative 2 or x is greater than 0. Okay, how many of you got that? Set builder, you guys get that? You should be able to go from the graph to the set builder or set builder to the graph, both ways there. Yes, sir?
Does it matter where you put it in? Like, if you put x is greater than 0 or 4?
Yes, it doesn't matter. You could put this first and then that over there. Mm-hmm. Good.
Can you do that with the number 9?
You could. It gets, so this is going back to number 9. And this is where I better be careful because I sometimes mix up. You could say, for that same one, x is any number such that x is less than or equal to 1 and greater than or equal to negative 3. So technically you can. Just make sure the arrows point the right way. I go with what the number line says. Like right here, negative 3 first, then 1. This is backwards from the number line. So still correct, but a little harder to see. All right, your homework, unless there's any other questions. Get you out of the way here. There. 19 to 41 odd. And then 66 to 68. I'll get the page in just a moment. $19 to 41 odd. And 66 to 68.
Do we need to graph each equation?
19 to 23, only graph it. 25 and 27, only write set builder. And then 29 to 41, both. So it says in the instructions like graph it, get the solution set, find a solution set, and graph it, depending on the problem. One moment here. 410 to 412. All right. Bye, so.